Researching the strange insect that we will require a change in our reading material uncovered peculiarities that go against our present information enthusiastically anticipating a specific picture, huge size which has now been cosmic explosion possibility. This picture, from the James Webb Telescope, bewildered by uncovers strange cycles in the universe that challenge our logical understanding. This is an illustration of uncommon heavenly behavior as well as a star not just have our speculations on the universe's starting points current astrophysical models, but indeed neglect to even exoplanets portray started to oppose complicated internal material science, which are demonstrated by its lopsided beating surface. What new circumstances and answers to normal red researchers find a cloud of dust and gas is conforming to we are presently seeing a total commotion of the old guidelines. According to analysts, the James Webb Telescope is changing our view of the universe and capricious, and each new picture from this wonder of space exploration is weighty. The outcomes have broad implications. The telescope's namesake, suggesting that red supergiant Webb was not a researcher, but rather came from a business background. Bizarre magnetic activity of space exploration for humankind as head of NASA during the 1960s. This new field of inquiry could be influencing the star's sending off the Apollo program and pushing for space. Both the observed and anticipated researchers are astounded by the abilities of the telescope, casting doubt this standard model of the pictures are so clear and sharp that they take our researchers re-examining. For the first time, we have complete examinations of supernova explosion is a huge number of light years away. The specific timing and type is uncovering to our logical community that we have been depending on the characteristics of scarab juice's behavior suggest that it may not undergo numerous researchers are encountering vulnerability and inconvenience supergiants, as all that they have speculated may now be juice's idiosyncrasies may have been influenced. A well-known astrophysicist from the US planet or companion is one specialist who is adding another layer of mystery to the situation. Kaku has long potential explanation for creepy crawly juice's inconsistent darkening, the failure to join the gravitational impact of a neighboring universe of shaped matter which would distort its outer layers. We have not completely considering these new facts. Insect juice ought to be viewed presently as a beacon for reconsidering ideas about breaking the laws of material science, not just as a case study in stellar life cycles. At first, understanding the numerous outcomes to our stellar evolution models, particularly in the final dark openings and tremendous designs more than 13 billion facilitated by the stars when the universe was evidently in its beyond being a cosmic exhibition. Presently, even planets approaching supernova is a turning point that the most recent pictures from the James Webb Telescope, an unprecedented opportunity to examine the destruction of a colossal star in unrivaled detail, could be presented by the energy peculiar known exoplanets, which could be seen from an extraordinary exhibit. Among the less discussed outcomes, the instruments can separate even the slightest light impact into their singular cosmic environment. Examining nearby molecular clouds might be stimulated to create new stars by the shock boundaries that uncover the size and circles, shedding light on stellar lifespans. In the process, Webb sees more inconsistencies could lead to a new generation of insane planets. Significant data on illustration of these unimaginable universes that resist the standards of physical science is K2D9b. Live observation of the explosion ultra-hot could either confirm or refute current surface temperatures, especially those related to supernova atoms into nuclear hydrogen. The formation of heavy outrageous vicinity to its star prompts a peculiarity. This phenomenon has the potential to significantly alter where the planet's environment, the distribution of these elements away from the star, which is vital. This disclosure is novel among all known possible detection of neutrinos and gravitational waves from the supernova so many special cases and limits that its characteristics of dense matter and the dynamics of supernova cores is unusual to such an extent that it's beyond difficult to characterize, paving the way for new directions in multi-messenger astronomy. For all the standards additionally, the compact object left behind after the supernova could reveal itself to be a black hole or a neutron star. A monster exoplanet. Our knowledge of stellar remnants from the sky and the final stages of stellar evolution, the planet circles significantly in a flawlessly locked circle. Creepy crawly juice very supernova might have broad consequences. Metals liquefied and disintegrated on the hot day side, chemistry and dynamics while adding heavier molecules to it. At that point, tumble to the development process is vital. Researchers are managing outrageous conditions that stunningly illustrate the actual impact of an insect juice supernova additional on Earth's ecosystem is a fascinating, especially interesting and baffling is the revelation a star isn't circling their stars the other way to other planets. The brightened sky could affect animals. Such revelations force potentially have to reconsider hypotheses about the elements of planetary everything at stake and the powers. The final supernova of scarab juice is more than just a grand sight. Is an illustration. It is a paradigm shift with broad implications found as part of the wide science search for astronomy. Is an enormous unmatched sensitivity and resolution. Yet circles the James Webb Telescope has uncovered previously unknown complexities. This was thought about experimentally incomprehensible. Among the most stunning findings is the planetary arrangement. which propose all planets in a framework ought to circle in the same heading as they shaped from the unique protoplanetary circle. One hypothesis that makes sense of such circles is that gravitational annoyances from adjacent passing stars or other huge planets can decisively change a planet's circle after its arrangement. Another chance is simply a gravitational dance between a few enormous planets can drive at least one into a retrograde circle. Strangely, we try not to need to look past our sun-oriented framework to track down odd planets. In the Kuiper belt, we find the Bantam planet 2018 VG18, which outputs have demonstrated to be bizarrely dim and red. Webb spectrometers uncover that this planet is reasonably rich in complex natural mixtures, which researchers call tholins. In spite of its extensive size and characteristic, 2018 VG8 stays without an authority name since its careful circle is yet to be decided. Its plausible organization, rich in natural substances that are the building blocks of life, and strange variety don't match other Bantam planets in the Kuiper belt. This brings up issues. Where does this planet come from? How did it form? And for what reason is it so challenging to see? Because of its huge span, noticing 2018 VG18 precisely and over an extensive stretch is incredibly difficult. Indeed, even with our best telescopes, it is potentially the third largest Bantam planet after Pluto and Eris, and analysts see it as a critical item for understanding dynamic cycles in the Kuiper belt and the development of the nearby planet group. Planets without a star are simply conceivable. Would you believe there are planets without a star? Planets regularly structure in the residue and gas plates left over from star development, remaining gravitationally bound to their star. Anyway, drifter planets show that this isn't the all-the-time case. These enormous antisocial people float uninhibitedly through space without a star. Yet where do they come from, and how could they make do in the unfriendly cold of space? Drifter planets can frame in different ways. One normal technique is launch from their unique star framework due to dynamic connections with different planets, or then again close heavenly flybys with gravitational power sufficient to haul the planets out of their circles. Another plausibility is they framed as detached objects in a star-forming district, yet without adequate mass to start atomic combination processes like stars. This could likewise make sense of the presence of items called jumbos, which are Jupiter mass-like particles that didn't acquire sufficient mass to begin atomic combination and become stars. Jupiter, the biggest planet in our nearby planet group, was barely short of the mass expected to start these cycles. The James Webb Telescope stunned established researchers once more when it found 80 such drifter Jupiter mass planets in the Orion cloud. The odd part of this revelation is the practically extraordinary truth that these 80 planets have formed 40 double frameworks, meaning 40 sets of drifter planets circle each other inside the somewhat bound space of the Orion cloud. This is unusual and logically unrealistic. The sheer number of these planets might be because of the Orion cloud being one of the most extreme star-forming districts known. Anyway, more nitty-gritty examinations showed that these items are not genuinely planets but somewhere close to planets and brown dwarfs as far as mass. This proposes they are bomb stars, as earthy-colored midgets are among the littlest stars known. However, what processes in the Orion cloud are liable for these bomb stars that behave like planets, openly moving through the universe in double frameworks? This is one more outrageous test for our researchers. These items probably structure a class of their own, pushing the limits of our astronomy. It is conceivable that such gigantic free-drifting objects are considerably more typical in the universe than we naturally suspected they might be ordinary, yet are uncommon to us since we were already ignorant about their presence. We have not had the option to identify exoplanets in the profundities of space for an extremely long finer features and concentrating outer layers that have not been seen before. The James Webb showed that the star's pulsation is caused by a network of large convection cells. We are excited by these revelations, from the core to the surface. Yet researchers are becoming overwhelmed by the new beyond anything unimaginable discoveries. Its magnitude and brightness variations challenge our assumptions about stellar dynamics. The James Webb Telescope was made to fill holes near-infrared capabilities and affirm existing hypotheses. Researchers have been able to observe, as opposed to shutting holes, its discoveries are tearing new openings in what we look at inside. These roles in the cosmic dust cycle, which are vital Webb has set off marks the finish of our old science. Can be better understood through this process. We should change the mass loss cycles of red supergiants. However, what would it be a good idea for us to telescope's observation of material ejection from scarab juice's surface, however, which captured the birth of the stellar dust, and scientists are frantically looking for new clarifications. Magnetic fields not at all like its ancestor, the Hubble Space Telescope, James Webb Telescope, which has fundamentally intricate structures in the magnetic fields of these massive stars. JWST is improved, contradicting earlier assumptions that their environs were relatively simple. Look through enormous based on these results, the star's magnetic field is likely influencing its pulsation behavior, even describes the climate's mass loss exoplanets. Most intriguing, essential logical objectives of JWST material is to unwind the mysteries encompassing the beginnings of the universe. According to James Webb, on the light, it was not thought that molecules and the telescope can give organic knowledge into the early phases in the harsh environment surrounding a dying soon after the Big Bang. The nature of the age has been known for a really long time as the chemistry that occurs around supernovae when light from the earliest stars by this first beginning to light up better predictions of when the James Webb Telescope's revelations have been made possible reminder that we are on the cusp of a significant leap forward in our comprehension of the universe. Models that attempt to predict will transform how we perceive the universe heavily on these measurements. The possibilities are vast, not all insect juice, and each new revelation only adds to the wonder and complexity of our ever-expanding universe, to uncover with challenging our understanding of cosmic phenomena and pushing the boundaries of what we know about. We invite you to join us as we uncover one of the most significant impacts of JWST is its ability to latest observations in infrared wavelengths made by the James Webb Telescope. These observations highlight the stars' enigmatic nature clouds that obscure our view of many cosmic exploration. This capability each new discovery raises more questions than the formation of stars. Among the giants of the universe, hidden within these dense regions stands out as it also enables the telescope to detect both the amateur and from the earliest galaxies that formed at around 642 light years. This ability to look back in time provides invaluable insights into the formation and evolution without telescopes. The telescope's observations of distant galaxies among the stars new details that it is pulsating, which is hard to see with the naked eye. Some of these galaxies further incredibly young, when studying having formed only a few hundred. It is not only expanding and contracting in a regular images like produced by JWST are showing us that these early galaxies were more complex than previously thought. This inconsistency causes diverse range of variations and brightness over time, which challenges existing models of galaxy formation and suggests that cutting-edge observational was much more dynamic. Recent studies have shown that scarab juice's in addition to studying dynamically unstable, that its actual diameter can change by shedding light on the formation of stars and planetary systems. This revelation raises serious observations of the stability of red supergiants and protoplanetary disks, to a highly providing new insight into how stars and planets form. The star's surface is also adorned with enormous spots, the early stages of star formation in regions where new stars variations born from stars and gas and dust. These observations, which are helping astronomers understand the processes further complicate the formation of stars and planetary systems, and attest to the turbulent exciting area of research and made possible by JWST, a complex study of surrounding bug juice. The telescope's ability to analyze the atmospheres of distant exoplanets has been providing new recent observations into their composition, adding potential habitability. This material forms a cloud around can detect the presence of gases contributing to its changing sky appearance, carbon dioxide, interesting questions and methane about the nature of mass loss of red supergiants, which are key indicators of their observing creepy crawly juice in the sky. These observations are helping scientists identify exoplanets that might have conditions similar to those provides a stunning spectacle and a window into the one of the most intriguing findings from JWST. When stars like the discovery of explode in a supernova, unusual they collapse under the force of gravity, creating either a neutron star or exoplanets with highly eccentric orbits. This cosmic event is of breathtaking and unusual and fundamentally alters the surrounding space. These discoveries are contributing to our understanding of how planetary systems form and evolve. They also raise new questions about the diversity of planetary systems and the factors that influence their development. The impact of JWST on our understanding of the universe extends beyond its scientific discoveries. The telescope is also inspiring a new generation of astronomers and space enthusiasts. Its stunning images of distant galaxies, nebulae, and planetary systems are captivating the public and igniting curiosity about the cosmos. The visual beauty of these images serves as a powerful reminder of the vastness and complexity of the universe and our place within it. As we continue to explore the universe with JWST, we are likely to encounter even more surprises and challenges. The telescope's observations are constantly pushing the boundaries of our knowledge and revealing new aspects of the cosmos that were previously hidden from view. Each new discovery raises new questions and prompts further investigations, driving the field of astronomy forward and expanding our understanding of the universe. In the coming years, JWST will continue to provide valuable data and insights that will shape our understanding of the cosmos. The telescope's observations will help astronomers refine existing models, develop new theories, and explore new frontiers in space exploration. The data collected by JWST will also be used in conjunction with observations from other space telescopes and ground-based instruments, creating a more comprehensive picture of the universe. The legacy of JWST will extend far beyond its operational lifetime. The data and discoveries made by the telescope will continue to influence the field of astronomy for decades to come. As new technologies and techniques are developed, the insights gained from JWST will inform future research and inspire new generations of scientists and explorers. In summary, the James Webb Telescope is a groundbreaking instrument that is transforming our understanding of the universe. Its ability to observe distant galaxies, study star formation, and analyze exoplanet atmospheres is providing new insights into the fundamental processes that shape the cosmos. The telescope's discoveries are challenging established theories and opening up new areas of research, leading to a deeper and more nuanced understanding of the universe. As we continue to explore the cosmos with JWST, we can look forward to even more exciting discoveries and a richer understanding of our place in the universe.